You ever been in one of those really long chats with an AI like Gemini, and you can almost feel it start to slow down? And you're just sitting there like, wait, what's going on here? Well, a big part of that is safety. See, making these powerful AIs safe for us to use is this huge, huge challenge. So, how do you do it without grinding the whole thing to a halt or making it so expensive that nobody can afford to run it? That's the exact puzzle we're going to crack open today. So, let's get right into it. At the heart of AI safety, you've got this classic, really tough trade-off. You want the AI to be safe, you want it to be fast, and you want it to be cheap. But for the longest time, it felt like you could only pick two. Making it safer made it slower and more expensive. This is the exact problem that researchers at Google DeepMind decided to take on. So just think about how an AI actually stops someone from misusing it. The best way to picture it is like there's a security guard standing right at the entrance to the AI's brain. And this guard's job? To read every single thing you ask it and decide, is it okay or not? As you can probably guess, with millions of us asking it all sorts of complicated things, that guard is under some serious pressure. Now, this is where the old way of doing things gets, well, kind of ridiculous. It created something called the long context problem. Imagine you hand that security guard a 1,000-page book and say, check this. With the old system, for every single new word you add to your request, the guard has to go back and reread the entire 1,000-page book from page one. It's just this brute force method that is incredibly slow and wildly expensive. Okay, but this led to a massive aha moment. The researchers started thinking, wait a minute, what if the guard doesn't have to reread everything? What if we could just give them a much smarter tool to begin with? And that's really the big idea in a nutshell. The old way, brute force, reread everything, all the time. The new way, it's like giving that security guard a magic highlighter, a tool that automatically flags the sketchy words and phrases as they appear, so the guard only has to pay attention to the parts that actually matter. No more rereading the whole book. So what is this magic highlighter in the real world? Well, in the research paper, they call it an activation probe, and what it does is pretty cool. Instead of waiting for the AI's final answer, this probe peeks directly inside the AI's hidden layers, its internal thought process, and it watches the signals in real time. It's been trained to spot the patterns that signal danger while they are forming, way before a bad response ever gets generated. And get this, here's a fun fact. To make these highlighters even better, what did they do? They used another AI. They had a system called AlphaEvolve, whose whole job was to automatically invent and evolve better and better versions of these probes. It's this wild meta situation of using AI to make AI safer. All right, so a smart highlighter sounds like a great idea. But what's the real world impact? Like for you, for the projects you're working on, for the apps you use? We're not talking about a small tweak here. This is a gigantic leap forward in efficiency. The proof is in the numbers, and they are wild. 10,000 times. That's the number. Let that sink in for a second. 10,000 times cheaper. These new activation probes are over 10,000 times more efficient than the old way of using a whole other giant AI to act as the security guard. This completely changes the math on what it costs to run AI safely. And this chart just shows you the breakthrough perfectly. On the left, you've got the old LLM monitor using a big AI to watch another AI. Super accurate, but crazy expensive. In the middle, you had older, simpler probes that were cheap, but they made a lot of mistakes. But now, look at the new probe on the right. You get the super low cost of a simple tool, but with the accuracy of a massive model. You're getting the best of both worlds. You don't have to choose between cheap and safe anymore. So how do you actually use this in a real system? You build what's called a cascading classifier. Think of it like the ultimate 1-2 punch. The super fast, super cheap probe is your first line of defense. It handles like 95% of everything that comes in. It's only for that small percentage of really tricky prompts where the probe isn't sure that it cascades it up to the big, expensive AI for a second look. The result? A system that's actually more accurate than just using the big AI by itself, but for a tiny fraction of the cost. Okay, so let's have some real talk. As amazing as this all sounds, this is not a magic wand. It's not a silver bullet, and to really get what's going on, we have to be upfront about the limits, because no defense is ever going to be perfect. And hey, don't just take my word for it. The researchers who built this are crystal clear about it in their own paper. They say jailbreak success rates are extremely high. We are a long way from adversarial robustness. So yeah, this new probe is a massive step in the right direction, but the bigger problem of stopping smart, determined attackers, that is far from solved. And you can see the proof right here in the data. Just look at that column for adaptive attack FNR. That's the false negative rate. Basically, how often the defense fails when an attacker is smart and knows how the defense works. The best probe still misses over 42% of those clever attacks. So what this tells us is that while it's great against basic attacks, a skilled person who has studied the system can still find a way to get through. Honestly, that's the best way to think about this whole field. AI safety isn't a problem you just solve one day and you're done. It's this constant cat and mouse game, an endless arms race. This research is an awesome new move for the good guys, but you can bet the attackers are already working on their next move. So, with all that said, what's the big takeaway here? How do you take these ideas and actually use them in your own work or just to understand what's happening in AI? Let's break it down into a simple playbook. All right, here are 3 key things to remember. First, smarter architecture can absolutely beat brute force. This whole project proves that a clever design, like these probes, is way more powerful than just throwing more computers and data at a problem. Second, combine your tools. The cascading system shows you can get better, cheaper, and more accurate results by layering fast, cheap models with the slow, expensive ones. And finally, the future is all about defending against adaptive attacks. The next big challenge isn't just stopping random bad prompts, it's building systems that can stand up to smart people who are actively trying to break them. And that really brings us to the final and maybe most exciting question of all. This kind of breakthrough doesn't just make the AI we have today safer, it opens the door for brand new things. So I want to leave you with this thought. If the cost of making AI safe just plummeted by 10,000 times, what would you build? Thanks for tuning in. Just so you know, this explainer was put together using Google's Notebook LM by Vin Nguyen, and it's all based on the research cited on screen. It's just for reference only.